Okay, let's recap what do all of these trig curves look like. So the first one we talked about was the sine curve. So with the sine curve, we noted that it started on a middle point heading upward. That was the basics for starting the curve. And then we decided that the amplitude, this is an amplitude, is normally what? 1. And a cycle or a period, so if I go here, travel, does this make sense? That point to that point completes a cycle. And this is normally, how long? 2 pi, a circle, full circle, 360 degrees. Okay. And then cos curve had the same amplitude, the same period, but what the difference was, it starts on a top, a max. Okay? But the next time I get to a max, that should also be 2 pi later, right? A period is still 2 pi, and our amplitude was still 1. Okay, let's say, I'll just use a sine. Okay, so I could do all these things either to a sine curve or a cosine curve. Okay, let's talk about that A. We know that that A, like when we talked about it before, it's a vertical stretch, right? What does it really change in regards to our curves? Remember what it changes physically? The amplitude. The B value, we know it affects the X, and it was that horizontal compression, right? So what characteristic is it changing on our trig curves? The period, the length. And C moves left to right, and D moves up, down. Which, I mean, they're going to affect all the points, obviously, but we're going to focus in on where's our new starter point. So if we looked at the sine one, it should have been on the origin, but now, like, where is it? Because it moved. Okay? And also for the D, we're going to dial in on where's our midline, right? That's really going to change where our middle is. It's changing everything else, but we'll dial in on where the middle is. Okay, so that's the info that we're trying to look up. Okay, here we go. Let's graph this one. We have an A, B, C, and a D. Okay, so my suggestion was to draw an AB graph. Just the A and the B. Okay, so it's a sine curve. So I'm going to start it here, heading upward. Unless sometimes there's a negative. Can you think about that negative, and then you have to start differently, right? So here's the sine curve. I'm going to kind of draw at least one cycle. So that's sine curve. A is 3. So what do I know right now? I know this max height is now 3 instead of 1. and this is now at -3. So the b is that value. So normally we do x divided by b. So this x coordinate was originally 2 pi. So I'm going to go 2 pi divided by b. What do you want to do with this dividing a fraction business? Should we flip it and multiply? So this now has an x value of 10. So the 2 pi was its original x value, but now it's 10. Okay, when you're doing this, it's probably a good idea to grab 4 x values. So what I do is I take that 10 and I divide it by 4. 10 divided by 4 is, you know what that would be? 2.5. So now this should be 2.5, 5, 7.5, 10. Okay, now we're going to do the shifts. So that's not your final graph. Okay, so I see, I'm going to do the midline first. So I see a +2. So to help myself out, I'm going to draw kind of a dashed line at 2, because I know that's going to be the middle. What's the highest height we're going to get to now? 5. So I kind of do that. And what's the lowest height? -1. Now I'm going to draw my 4 ticks. Okay, this one's kind of awkward because our x values are not really matching what we're going to be shifting here. We're going to be shifting right 1. So we're going to have to kind of be in between the tick marks. Okay, ready? Midline is now at 1. So see how I'm kind of in between ticks here? I'm at a top at 3.5. At 3.5, I'm at a top. At 6, I'm back to a middle. I'm adding 1 to these x values. At 8.5, I'm at a bottom. 8.5 at a bottom. And at 11, I'm back to a top. Oh, no. Sorry, I'm at a middle. Supposed to correct me there. I'm at a middle. You already had that on your paper, though, I'm assuming, right? Did we do it? Mid, top, mid, bottom, mid. Can we work to get another coordinate? What's the coordinate before this one? We'd be going to the bottom, right? Anybody know what the x value would be? Negative 1.5? Because before that x value would have been a negative 2.5. So now it's negative 1.5. Okay, so I might have questions for you on your test, like what's the amplitude? 3. Right, we're stretching up and down, 3 above it, 3 below it. The period was 10. So we did 2 pi divided by b, that's the period. The midline. How do you create an equation for the midline? It has to be an equation. So what are you going to do for 2? Y equals 2. Because it's always the y height of 2. And where's the new starting point? So what is the coordinate? So this is the shift. What is the coordinate there? 1, 2. Right? I moved right 1 up 2, and that's where I was starting from. And really, I'm not memorizing point by point. I'm just thinking from middle, top, middle, bottom, middle. Okay. Next, I'm going to graph 2 sine x, just that right now. Okay, because it's inside the bracket, so I'm going to vertically stretch first. I'm going to vertically stretch this thing first. Okay, so that's all I changed was just the 2 and a negative 2. Now, what does this mean again? These brackets. Absolute value. And then this means down 1. What should I do before what? I should absolute value before I do the down 1. If it looked like this, what would you do? Down 1, then absolute. Okay, do you see a difference? This says to absolute it and then go down. This says to down and then absolute. Okay, so I'm going to absolute value this. So if it's 0, leave it. If it's positive, leave it. If it's negative, so that chunk there needs to become positive. So that's an absolute, right? Leave the positive stuff, leave the 0 stuff. Okay, and then our final graph. We need to now shift it down 1. Okay, so you can see how order of operations is so important when you're graphing transformations.